All right, so welcome to the second half of our math book. We're ready for chapter 7. Now, chapter 7 is all new information. I introduced it a little bit to you when we got into the order of operations. If you remember that OOO, where we had asked for several extra presents from my dear Aunt Sally. So we have exponents that we're going to be getting into for chapter 7, lesson 1. Now, on top of that, then we're also going to have the review, and that's stuff that we haven't done since before Christmas break. So we got to go back and be willing to ask some questions. Now, I got a new setup in our classroom, so hopefully we get some better options for team building and collaboration to go on and talking to one another and helping each other out. So please feel free to do that. Come back to the back of the room, ask for help when you have questions on it, but especially on those review questions you may not remember because it has been a couple weeks since we've been into it. But come and ask or ask some peers in your class. We'll be willing to help. When we get into the idea of exponents, it looks like really tricky math, but once you get it, you don't struggle with it. You just have to pay attention to what it means. There's two parts to an exponent, always two parts. You got the power and then, or the exponent, and then you have the base number. So when we start looking at them, they give you some very specific information and they have you focusing in here. I'm just going to enlarge that a little bit so you can see it. When we talk about exponents, it says an exponent is a number that tells how many times a number called the base is used as a repeated factor. So when we have the base, the 5 in this case is the base. It's the main number that we're going to use and we're going to stick with. The exponents then does the repeating. It's going to be multiplied by itself so many times. So if I see a base of 5 and an exponent of 3, the exponent tells me to write the 5 down, always in a multiplication problem, 3 different times. Now I kind of emphasize that because these are always multiplication. They're never addition, subtraction, or division. They're always multiplication. So I know then my exponent is going to be written down 3 different times for my base. So my exponent says, hey, take the base, the 5, write it 3 times with multiplication signs in between them. That's what that means mathematically. Now you may hear me also call it a power because an exponent and a power are the same thing. They're synonyms for one another. I get confused every once in a while because our last program that we used to use always used the word power when we talked about exponents. So I will use both of them, but they mean the exact same thing. If I have 3 5s written in a row and they say, now write that as a math problem or an expression. An expression is just a math problem without an answer to it. You're fine. Okay. Then I would have to say, well, there are 3 of them, 3 5s. So my number that's repeated is my base, and I just count how many there are. That's my exponent of 3. So as I'm going through and I'm solving these then, they're going to give me several scenarios to introduce me to exponents, what they mean, how they work, what I would end up with once I solve for them, or they may give me a number and I have to turn it into an exponent. So this says, the table shows the number of bonuses a player can receive at each level of a video game. So we have level A, B, C, and D. Use an exponent to write the number of bonuses a player can receive in level D. So as we're looking at it, the way it is set up, so these are just the directions more enlarged. As we work through it, it says the number blank is used as a repeated factor. So it's asking what is the base. And when I look at it, I have 1, 2, 3, 4 3s. So I know the base, the repeated factor, is my 3. Then it says the 3 is used as a factor how many times? Well, 1, 2, 3, 4 times. So I know that if it's used 4 times, then I would write that as it with an exponent onto my base. So I'd have a base of 3 with an exponent of 4. A base of 3 and an exponent of 4 tells me if I therefore want to solve for it, then I'm going to take 3 times 3 times 3 times 3, which is that. If they continue on with the information, then it says, so a player can receive blank bonuses in level D. Well, what does that equal mathematically? This is where our handy dandy calculator is going to be your best friend. Okay, so the first thing you have to do is you have to write it out in the math problem. That's going to be showing your work. That's how you get your point for showing your work. So it would just be the 3 times 3 times 3 times 3, which is what we started out with. If I want to do it by hand, which there's nothing wrong with it, but I'm not going to require it as long as you get to the right answer. But if you want to do it by hand, then the way I do it is I connect the two that I'm going to use first. Now, we talked about order of operations. My dear, multiplication and division happens from left to right. So I'm always going to multiply from left to right. So I know 3 times 3 times 3 is 9. Well, then I'm going to go to my very next one. So I continue to use these little lines or arrows to show what my next math is. I know I'm going to take my 9 and I want to multiply by the next thing that I have. I don't want that to be in a box. So I'm going to take my 9 times that 3, which gives me, well, 9 times 3 is 27. Therefore, I have 27, but I still have more math to do, so I want to multiply it by 3. So 9 times 3 is going to be 81. Excuse me, 27 times 3 is going to be 81. So when I get to the 81, I know I get to the final answer. Now here's another thing you can do. You can take your handy dandy calculator and do 3 times 3 times 3 times 3 equals, and you're still going to get 81. So either way, if you want to do it by hand and show every step that you do, you feel more than welcome. If you want to write it out to the side, 3 times 3 equals 9, and then 9 times 3 is 27, and then 27 times 3 is 81, that's fine. Or as long as you have it set up for me in the multiplication problem, show me what it is, and then you type it in your calculator and get 81, I'm good with that as well. 1 point for the answer, 1 point for the math problem that you're solving. All right, so let's see what the directions say, because our directions, we're going to have a couple different types of directions for these specific problems. Use one or more exponents to write the expression. So once again, where there's a difference between an expression and an equation. Now, I introduced this to you a couple months ago in the first semester, and it's fine if you don't remember. Expressions are math problems without answers. Equations are math problems that also show me an answer. So these are going to be expressions, but I got to make it an expression that only uses an exponent or a set of exponents. So when I look at it, I'm looking to see if I have the same base throughout. All of those are 7s. I do have the same base throughout. So the number 7 is used as a repeated factor. Repeated factor is just what that base is. How many times is it repeated then? Then I count. 1, 2, 3, 4, 5 of them. So I know I have an exponent, a repeated number, 5 times. So when I write it as an exponent, then I have my base first. It's always going to be larger. With my exponent to follow, and it's always going to be floating up in the top right-hand corner. So I know I have 7 to the 5th power, or 7 with an exponent of 5. Okay? So if I wanted to solve for that then, it doesn't tell me to, but if I wanted to solve for it, then I would have to have the math problem, 7 times 7 times 7 times 7 times 7, and type that into my handy dandy calculator to get the answer. Now when I look at B, I start with my bases. Do I have the same base throughout? And that answer is no. So I'm going to have 2 different bases. Now notice, in between every single one of these factors, there's a multiplication sign. So it has to be multiplication also between my 2 bases. When they go to write the final answer down here, notice they have that multiplication sign there for you. That's important. You can't have a comma, you can't change it to addition or any other type of math function. It has to say multiplication. I notice that I have a 6 and an 8, so those are my bases for my 2 exponents that are going to make up this expression. I see how many times the 6 is repeated. Well, there's 1, 2 of them, so 2 times. That's going to be an exponent there. And then how many times is the 8 repeated? 1, 2, 3. So that's going to be an exponent of 3. So I'm going to put the 2 with the 6. So I have a big 6 and a little 2. So notice I made the 6 and the 8 larger just because it was hard to make the 2s and 3s small enough to where you could actually read them. And my exponent of 3. Now, there are times with exponents that they have special names. Right? So if there's an exponent of 2, we can say an exponent of 2, we can say to the power of 2, or in this case, this is also said squared. With the 8 to the 3rd power, or 8 with an exponent of 3, we could also say that that is 8 cubed. So if we think about labels, which we're going to get into geometry here, not here, here in just a couple of weeks. Wasn't saying that correctly. We got to know that area always has a squared label. So if we had squared feet, we knew we would have feet with a small 2 up above. When we get into volume, filling up a container, an amount that goes inside, then that always has a cubic label. So we could have cubic feet, cubic miles, cubic gallons. Okay? So we have to know that those are also extra names that we can call the 2 and the 3. All right, so this one says then we're given the expression of 10 to the 3rd power. Now we got to find the value of it. So we always have to remember that this is always multiplication. It's never anything different unless they show you something different. So the first thing I have to do is get a point for showing the math problem that I have to solve. And that is by taking the base and writing it as many times as the exponent tells me. And it tells me to write it 3 times. So this is 10 to the exponent of 3, 10 to the 3rd power, also known as 10 cubed, because that 3 tells me that it's cubed. But I'm going to write it down as 10 times 10 times 10. I have to write my base of 10, and I have to write it 3 times because my exponent tells me to. This gives me a point. Now you can take your handy dandy calculator and type it in 10 times 10 times 10 equals, you're going to see what the answer is. You can do it by hand. You can show the 2 arrows or the 2 lines connecting, and I can do 10 times 10, which is 100. And then I can take 100 times 10, which is 1,000. If I do it on my handy dandy calculator, I still also see that the value is 1,000. Now we're not dealing with auxiliary problems, so there's no label here. So these are only going to be worth 2 points. One for showing the math problem that I'm doing, one for showing the correct answer. Now this one says 7 to the 1st power, or 7 with an exponent of 1. Well, if I take 7, and I'm not really multiplying by anything, am I? Because it's already written 1 time. So that's one of those mathematical rules that are always going to happen. My base of 7, I really don't have an exponent because it's written 1 time already. That means it's just simply 7. So one of my mathematical rules to learn in this lesson is that any number with an exponent of 1, so that little itty bitty number that's in the top right hand corner, means the number is going to stay the same. Even if it's 1 million to the 1st power, it's still going to be equal to 1 million. One that they don't quite introduce us to yet, okay, but I'm going to go ahead and add it to this slide, is that any number with an exponent of 0 is always 0, because it's telling you to write down some number 0 times. So you're not actually writing anything down at all. So an exponent of 1 means the number stays the same. An exponent of 0 means the answer is always 0 and nothing else but 0. All right, so now let's look at this one. It says to write 81 with an exponent by using 3 as the base. So now, first question that I would always have is, well, will 3 go into 81 evenly? So I have to go all the way back to the first 2 weeks of school when we did our divisibility rules. We said that if I take the number 81 and I add the digits, 8 plus 1 equals 9. Does 3 go into 9 evenly? And it does. So this will work. So they have the long way of doing it, and I'm going to show you what I believe to be a quicker way here in just a moment. So they say, well, let's start out with 3 times 3. 3 times 3 is 9. So an exponent of 2 doesn't work. So let's try an exponent of 3. That would be 3 times 3 times 3. 3 times 3 is 9. Times 3 is 27. That doesn't work. So let's try 4. 3 times 3 times 3 times 3. And when I type that into my handy dandy calculator, I get 81. So I know that my answer is going to have to be written as 3 to the power of 4, or with an exponent of 4. Now, what I seem to think is easier to do, that I find that most of my students are more successful with, is going back to, I believe it was chapter 2. I could be off on that, but I believe it's chapter 2, where we looked at finding prime factors and prime factorization. If I take 81 and I know that 3 has to be my number that I'm going into it, Then I'm going to divide by 3 over and over and over again until I don't have anything left over. So I know that I'm dividing by 3, and 3 goes into 81. If I take my handy-dandy calculator, remember to start with the number inside the division box, 81 divided by 3 equals, I get 27. Got to keep going. So I'm going to divide my 27 also by 3. And 3 will go into 27. 27 divided by 3 equals, that's 9. I got to keep going. 3 will go into 9 3 times. I've gotten to where I need to be. So my prime factorization shows me that I have 1, 2, 3, 4 3s, which is what we said the answer would have to be. It would have to be a base of 3, because that's what it tells me that I'm going to use. And then I count how many there are for my exponent. There are 4 of them, so it would have to be 3 to the power of 4, or with an exponent of 4. All right, so now this is one of my explanation questions that I have to do. Explain how to write repeated multiplication of a factor by using an exponent. So seeing a multiplication problem where it's the same number, how do I write it as an expression using an exponent? So the first thing I have to do is figure out what my base is. The repeated number is written as the base number, and then, so there's 2 steps to it, right? So I first have to know what my base is, or my large number, if you want to call it the large number, but mathematically it's called the base. So the repeated number is my base, and then I have to figure out what that exponent is. And then you write the number of times it's repeated as the exponent. Okay, so if it's written 14 times, I want to have, let's say it was 2 to the 14th power. I have 2 times 2 times 2 times 2 right now 14 times. So I have a base of 2 with an exponent of 14. Step 2 says, is 5 to the 2nd power, or 5 squared, equal to 2 to the 5th power? Explain why or why not. Well, I'm going to tell you that, no, they're not equal to one another. And the reason they're not is that, well, I have to explain how I found that out. Well, I find that out by doing the math. I know that if I take 5 squared, or 5 to the 2nd power, that would be 5 times 5, which is equal to 25. If I take 2 to the 5th power, that would be 2 times 2 times 2 times 2 times 2. And when I type that into my calculator, I equal 52. Those are not the same. That's how I know. I did the math, but I used the math in my explanation, so I get my 2 points, because I have to have no first, and then I have to have a complete explanation as to why it's not the same. All right, so now let's look at these practice problems. The first one says, write 2 to the 4th power by using repeated multiplication. Then find the value of 2 to the 4th power. So it means basically first write out what the math problem would look like. So 2 to the 4th power would look like, now those 2's are pretty small, so I have extra ones in there, just so you can see them. But I have to have an extra 2 of them. So I have 2 times 2 times 2 times 2. So I showed my work, that's my first point. Then when I type it into my calculator, 2 times 2 times 2 times 2 equals, I get 16. I get my point for my answer. This one wants us to go in reverse. Here's the math problem written out. Now I need an expression. Once again, an expression is a math problem without an answer. So I don't need the answer, I just need to know how it would be written as an exponent. So I have a base of 1, 2, 3, 4. I have 7 as my base, written 4 times. So my base is 7, 4 is my exponent. I come over to 3, I have a 5, which is my base. How many do I have? 5. I have 5 of them. So I have a base of 5 and an exponent of 5. And then over here I've got 2 different ones, don't I? I have 3 times 3 times 4 times 4. So I know I have to have 2 bases, and it has to be multiplication in the middle, because expressions of exponents are always multiplication. So I know I'm going to have 3 times 4 as my base, and then I have 2 3's, and I have 2 4's. So I have 3 to the 2nd power times 4 to the 2nd power, or I could say 3 with an exponent of 2 times 4 with an exponent of 2, or the other way I could say that is 3 squared times 4 squared. All right, now, if I wanted to solve those, it doesn't tell me to, but just in case you're curious, then if I typed in 7 times 7 times 7 times 7 equals, I get 2,401. It's a lot bigger number than a lot of times we think of, but every time we're increasing that number by 7. If I do 5 times 5, I end up with 3,125. And then when I do 3 squared times 4 squared, I have to do the two individuals first. So 3 times 3 is 9, and 4 times 4 is 16. Then I can do my 9 times my 16, which is 144. All right, so these are what your practice problems are going to look like, or excuse me, your homework problems are going to look like. So let's make sure we're following along, filling out our book, writing out what needs to be written out, and writing the correct answers. If all I do is write down a bunch of answers, you're not listening to me, then you're not getting the lesson and understanding it. So I have 20 squared. I'm finding the value. So the first thing I have to do is write out the math problem that I'm doing. The math problem that I'm doing is 20 times 20. That's my first point. Do it by hand and stack them and multiply them and get the answer, or type into your calculator 20 times 20 equals, and you're going to get 400. Second point. This one, there's no work that you have to do, because that's one of those special rules. Remember, you had 2 of them that had special rules. If there's an exponent of 1 or if there's an exponent of 0. If there's an exponent of 1, then it's just the answer by itself. So all I need is an 82 to get my point. For number 7, I have to write out my math problem. For my first point, it tells me to use a base of 3, and I'm going to write it how many times? 5 times, right? So I have to write out 3 times 3 times 3 times 3 times 3. Then I can solve for it. Typing into my calculator, I believe, would be easier. You could do 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and then 81 times 3 would be 243. Or I could just type in 3 times 3 times 3 times 3 times 3 equals on my calculator and get 243. This says write 32 as a number with an exponent by using 2 as the base. So if I use my prime factorization, where I do my division box until I don't have anything left over, I know I have 32 as my value, and I'm going to use my prime factor of 2 until I run out. Then I should be good to go. So I'm going to take 32. I know I'm going to divide by 2, and that's going to be my base number because that's what it tells me. I'm going to use 2 as the base. So I divide by 2. Well, 2 goes into 32 16 times. Then I got to divide again. So 16 divided by 2 is 8. And I divide again. 8 divided by 2 is 4. And I divide yet again. And 4 divided by 2 is 2. I have a final answer of 2, so I know I've gone as far as I need to or as far as I can. So then I count how many there are. There are 1, 2, 3, 4, 5 of them. So I have an exponent of 5. So when it says to write the number with an exponent, or it may say write it as an expression. This is also expression because that is a math problem, just written in exponent form. All right, so we got 9, 10, 11. I'm just going to put them at the top of the screen here. Complete these statements with the correct exponents. Well, how am I going to know what that exponent is? Well, I'm going to do what I just did on that last one. I'm going to take the total answer, I'm going to divide by the base and find out how many times I'm going to use it. So I'm going to take my 125 and I'm going to divide by 5. Well, 5 goes into 125 how many times? 5 goes into 125 25 times, but then I have to divide again. I'm going to divide by 5, and 5 goes into 25 5 times. So I have my base of 5. It's already there. My exponent is, well, how many of them did I use? 1, 2, 3. So I have an exponent of 3. So 5 to the third power, or 5 cubed, or 5 with an exponent of 3, is equal to 125. I know that because we just proved it. On this one, there's no work to do. They're saying it's 16 with an exponent, and the answer is equal to 16. So all I have to remember is that special rule that if it has a 1 as an exponent, then it has to be equal to the number that I'm starting with. Number 11, so I have 900, and I'm going to use a base of 30. So if I just take my 900 divided by 30 and see how many times it goes into it, I'll keep going until I can't get any more 30s. Well, 30 goes into 900, handy dandy calculator, 900 divided by 30 equals, I get a 30. Easy enough. So my base is 30, and how many are there? There are 2 of them. So I have 30 to the second power, 30 to the exponent of 2, also known as 30 squared. All right, so moving on, wrapping up the lesson. So this is question 12. Find question 12 in your book, should be the very next one. It says find the value. So this is a multi-step problem that I want you to do and think about. It says to find the values of each of these exponents, and then think about what the pattern is. Find that pattern, make a prediction for the next one. All right, so I want you to think about what it says. I'm going to read it to you. Think about what I'm saying and what this says, and then I'm going to have you do it on your own, and then come back to the video and check how you do. First, step 1, find the values of 4 to the first power, 4 squared, 4 cubed, 4 to the fourth power, and 4 to the fifth power. Step 2, look for a pattern in your results and use it to predict the ones digit in the value of 4 to the sixth power. Pause the video, do the work, come back to me, see how you did. All right, so hopefully you've done as I've asked, okay? And you've tried this. Now, I'm not expecting you necessarily to get it right, but if you did, fantastic. Just wanted you to try it because we're not used to getting back into these harder, deeper questions. All right, so first thing everyone would need is several different answers up here. So I have 4 to the first power, so that's just 4 written down, right? So that's step 1. 4 to the second power, that means I have to do 4 times 4, which is equal to 16. 4 to the third power, or 4 cubed, would be 4 times 4 times 4, and when I find that answer, that's 64. 4 to the fourth power, so 4 times 4 times 4 times 4 equals 256. And then 4 to the fifth power, so 4 times 4 times 4 times 4 times 4 equals 1024. My second thing that I should have done then is try to find a pattern. Now, they give you a hint about the pattern because they say to predict what you think will be the ones digit when I do 4 to the sixth. So let's look at the ones positions. Notice I have a 4, a 6, a 4, a 6, a 4. So I should see a pattern. 4, 6, 4, 6, 4. So if my pattern is 4, 6, 4, 6, 4, then my next number should have a ones digit of 6 if it follows the same pattern. The pattern is 4, 6, 4, 6, 4. So we would predict it to be a 6. You can find that by doing 4 times 4 times 4 times 4 times 4 times 4 equals, and you will see that indeed in your ones position, there is a 6. All right, so this is the last one that I want you to do on your own. It says to select the expressions that are equivalent. Remember, equivalent, equa means to be equal to. So it has to have the same value of 32. Mark all that apply, and I will tell you it's more than one answer. Okay? So I want you to mark all that apply, then come back to me and unpause the video and check to see how you did. So hopefully you have work shown, so you can get credit if this was actually a homework assignment, and you have more than one checked. I'm going to tell you, you need 3 of them checked. So let's look at what these are equal to. So I have 2 times 2 times 2 times 2 times 2, because my base is 2 and it says an exponent of 5. I should have 5 of them right now, and then when I type that into my handy dandy calculator, I get 32, and that's what I'm looking for. Check. This one says 8 to the fourth power. So 8 times 8 times 8 times 8 is 4,096. Not even close to 32. So this is a 2-step math problem, right? We haven't looked at those, but I was hoping you would think logically as to what that would equal when you did the steps. So you should have started with 2 times 2 times 2, and that would give you 8. So my 2 to the third power gives me 8, and 8 times 4, which is what is left, is 32. So order of operations, I have to solve for my exponents first, then I can do the other math that's in the math problem. And then on D, order of operations tells me I have to go from left to right. And 2 times 4 is 8, and 8 times 4 gives me 32. So you should have A, C, and D checked off as being, yes, those are equivalent to the 32, and B does not work. All right, so last thing I want to remind you of, because you might see this hint in your review on the back of the paper of your assignment. Remember that we did the metric system before Christmas break in chapter 6. We talked about King Hector doesn't usually drink chocolate milk, and that my unit is in the middle. So that is either my meters, my liters, or my grams. And I go from kilo to king, and as I move down, I move my decimal to the right that many times. Whereas I'm going up to the king, I'm going left, I'm going to move my decimal to the left that many times. Hopefully you remember how to do those. All right, so your assignment, you have 2 through 11. Yes, I want you to do, and I will expect you to do number 11. It's worth 2 points at the bottom of your paper. So you have 2 through 11 on page 361. And then on 362, you have the 1 through 6, the last four being review. So it's about a half-hour video to introduce you for the first time to exponents. Hopefully you don't find it difficult as long as you're paying attention and follow along, because it really is an easy concept. It's just remembering that the big number is my base. My exponent tells me how many times to write it down. Then it's always multiplication. No other math other than multiplication when I'm doing my exponents. As you're working through it then, feel free to rewatch the video if you need to. If you have questions, come and ask, or work with your groups and help each other.